ERDC takes on highly interdisciplinary research areas that are of critical importance to the U.S. military and Army operations. What this means is we work with highly interdisciplinary teams of scientists and engineers. So we could have mechanical, civil, electrical, and even chemists all working together. In addition, CREL is the federal government's only laboratory with a cold regions focus. And so this means that our mission space is even more unique, and we take on challenges that are even more unusual in the field of science and engineering. My research group focuses broadly on ice materials science. We are both taking on the challenge of ice as an adversary in trying to mitigate icing catastrophes, but we're also looking to leverage ice as a resource, as an indigenous material for constructing and building in cold regions. With ice as an adversary, we're focused on ice adhesion. And in this topic space, we are working on developing an analytical framework for analyzing and understanding ice adhesion across length scales. In ice adhesion, we are working on transitioning coating technologies to military assets. What we mean by this is the current Army guidance for icing scenarios is to shelter in place. It's not hard to imagine that this could be a problem or put the military at greater risk for them to stop moving in a contested area. So we're working on developing an analytical framework that will help decision makers understand what to expect from coating technologies and ice mitigation technologies and deploying them on their assets. In leveraging ice as a resource or an indigenous construction material in cold regions, we're studying the mechanical, thermal, and optical properties of ice, both pure ice and ice with impurities, to better understand how to leverage it strategically for construction in cold regions. We're thinking about how can we make ice stronger in the field for ice bridging and roadways and runways, but also how can we build vertically with ice by ensuring that we have a high strength and a melt-resistant composition. Our work on ice as a resource will benefit the U.S. military by developing methodologies and formulations for constructing with ice as an indigenous material, where in the Arctic regions, building materials are often very scarce.